Hello, welcome to the next video in this pretty long set of videos. D.1 and D.2 are really two sections together. And this is where D.2 basically starts, where we're solving equations, where we are trying to take equations like this and figure out what values of the variable x makes each side equal. So first with x squared equals 9. Well, let's see. You just want to think of a number that you can square to get 9. So, 3 squared is 9. So that means x equals 3 is a solution. And also, negative 3 squared is also 9, because a negative number times a negative number is a positive. So that means x equals 3 or x equals negative 3 works. All right, what if you had something more complicated, like for part C or D or E? We're going to need some other tricks other than just like looking at it and thinking about what works. And the trick is at least for problems like this, when you have something squared equals 9, is you can take the square root of both sides. So that's the method we're usually going to use. So I'm just going to write this out again. X squared equals 9. So the square root cancels out with x squared. Maybe I should do a quick review of square roots right here. We're going to do this on both sides. So the square root of 9, just on the side here, what does that mean? That whatever that is, it's a number it's a positive number that you can square and get 9. So it's basically solving this equation, and you see that 3 works there. So another thing about the square root symbol that a lot of people get mixed up that we should go over right now, the radical, it only gives you a positive square root. So saying that the square root of something equals something else means the result must be a positive number. So saying the square root of something equals this means the same thing as this. And you might be thinking, well, what about the negative 3? Isn't the square root of 9 plus or minus 3? Well, no, because this is actually part of the definition of a square root, which I'm writing out here. So the square root of a equals b means that result, b, is a number you can square, and it also means that's greater than 0. So you can check that with a calculator if you don't believe me. I have to open my calculator. So if you do second square root button and plug in 9, is it going to give you plus or minus 3? No, it just gives you 3. So yeah, so the radical symbol here only gives you positive square roots. But this equation here still has two solutions. Negative 3 is still just as much a solution. So that means, like, this would just give you x equals 3 if you just do it like that. But taking the square root, you need to always remember to include a plus or minus, because both positive 3 and negative 3 are solutions. So those agree with each other that way. So that's a moral of the story here. So I wrote that out here. And remember, if you're not able to write things down as fast as I'm saying them, it's a good idea to pause these videos, rewind it if you miss something I said that you might need to understand, because these do go faster than lecture in class. Anyways, let's look at x squared equals 4. With this one, I'm going to do the same thing. I'm going to take the square root of both sides. But include a plus or minus on one side. The square root of x squared is just x. Those are opposites. And the square root of 4, radical 4, is just 2. So we have plus or minus 2 on the other side. So 2 squared is 4, negative 2, if you square it, negative 2 times negative 2 is positive 4. So that's that. Okay, this one is a little bit more complicated. We can still cancel out the exponent of 2 by doing a square root, but the trick here is that we have the 3 here. So if I were to just do a square root to both sides right here, it's not going to like distribute into these two terms in any kind of nice way. It doesn't distribute at all. So it's not going to cancel anything out here. It's just going to leave you with a big mess. So instead of doing that, we're going to add 3 to both sides. And that will give you x minus 1 quantity squared equals 16. At this point, now if you just have something to the power 2, you can take the square root of both sides. That will cancel that out. Include the plus or minus on one side, and the square root cancels out with the power of 2, and you just get x minus 1 over here, and the radical 16 is just 4, so we have plus or minus 4 over here. Add 1 to both sides to cancel that out, and you end up with x equals, here, be careful, this doesn't turn into just plus or minus 5 when you add these up. It's going to be, if you do positive 4 plus 1, that's 5. Or you could have x equals negative 4 plus 1. And this is tricky because numbers add to negative numbers in a different way than they add to positive numbers. So this turns into x equals 5 or x equals negative 3. And just like with every other kind of problem, I always recommend checking your answer, as not only to check your answer, but just as a way to get a deeper understanding of why this works. So I'm going to replace the x with 5 here and do 5 minus 1 squared minus 3 equals 13. See if that works. 5 minus 1 is 4, so you got 4 squared minus 3. Is that 13? 4 squared is 16 minus 3 equals 13. So that checks. And then with the other one, negative 3, if you do negative 3 minus 1 squared, is that equal to 13? So negative 4 squared is positive 16. Anything squared is always positive. So 16 minus 3 is 13. So that checks too. All right. All right. So let's go on to part D here and E. These are a little different. Like if you were to FOIL this out, you'd have an x squared in it, but you'd also have something times x. It wouldn't be something you can just take a square root of. But the trick is that you have two things being multiplied together, here is what this is saying, to make 0. And the trick is this fact that anything times 0 is equal to 0. So I just wrote that out here. 0 times anything is 0, and anything times 0 is 0. It doesn't matter which way you do it. So that means if you can find a value of x that makes x minus 2 equal to 0, then that would be a solution. Or if you can find a value of x that makes x plus 1 equal to 0, then that will be a solution too. So let's try it. If you add 2 to both sides, you'll get x equals 2. Here, if you subtract 1 from both sides, you'll get x equals negative 1. So those are the solutions, but let's just check again, because checking is going to help you understand why this process works. So if you plug in x equals 2 here, you're going to do 2 minus 2 times 2 plus 1 Is that equal to 0? Yeah, 2 minus 2 is 0. 0 times 3 is equal to 0, so that works. With the other one, let's plug in x equals negative 1. That's going to look like negative, negative 1 minus 2 times negative 1 plus 1. Is that equal to 0? Let's see. You'll get negative 3 times negative 1 plus 1 is 0. Negative 3 times 0 is 0. So that works. Those are your two solutions. All right, so for this one, trying to keep the work separate here. This one isn't really factored. So you can't really say anything about this right now. You might think about, like, what if you subtract the x from both sides? If you don't want to write this down, that's okay, because this is not the way to do it. And then take the square root of both sides here. This doesn't cancel. Cancel. It does not cancel. Because, like, you got the 5x there. The square root doesn't distribute over these two terms. It just doesn't work. So that doesn't help. So we do have 0 on one side, just like we had over here with this one. But the right side is not in factored, the left side is not in factored form. But could we factor it? Could we take this x squared plus 5x plus 6 and write it as something multiplied by something else that gets you 0? And if you did the factoring exercises up above, maybe you can deal with this. We're going to get, let's see, x times x is going to make x squared. Whatever goes here and here needs to multiply to make 6. And these two numbers, when you FOIL it out, you're going to get the yellow 1 times x plus the blue 1 times x. They need to add up to 5x. So they need to add up to 5 and multiply to make 6. What will work is 2 and 3. If you want to check that by foiling, pause the video right now. That's a good idea, because foiling practice is important for understanding this stuff. So we've got it factored on the left side, and the two parts here are multiplying to make 0. So those two factors, x plus 2 or x plus 3, could be 0. So if x plus 2 is equal to 0, you could subtract 2 from both sides. That will give you x equals negative 2. Or if you take the x plus 3, that could be 0 too, and subtract 3 from both sides, you'll get x equals negative 3. So those are your two solutions of this one. And it's a good idea to plug them into the original one to check. So for these next exercises, these are ones that are super important to get practice solving yourself. Not just the homework, but try it before you do the homework and before you watch the next videos, because this is a really important skill. We're going to be using this kind of skill, solving equations that look a lot like this, throughout chapter 3, and also a lot here and there in other chapters in the book. So the more practice you get, the better. And so I'll talk to you in the next video after you've tried these.